We've been on the hunt for oil and gas for over a century now, but the crazy thing is, these resources are buried miles down, completely invisible. So, how do we actually get better at finding them? Well, today, we're going to dive into the high-tech revolution that's totally changing the game.
Okay, let's just jump right in. The core problem here is, well, it's massive. I mean, how in the world do you see something that's miles under your feet without, digging a ridiculously deep hole? It's exactly like an invisible treasure hunt.
So, let's really tackle that main question. If you can't see it, and you can't touch it, how do you even start to create a map of it? Well, the answer, it turns out, isn't about digging, it's about listening. And that brings us to the core technique here, seismic exploration. What we're doing, essentially, is creating our own seismic waves. Think of it like a tiny, super-controlled earthquake. And then, we just listen for the echoes. By analyzing how all those waves bounce back, we can literally build a 3D picture of everything underground. The best analogy? It's like giving the entire planet a CT scan. Seriously, that's the perfect way to imagine it.
Okay, so what does this CT scan for the Earth actually involve? Well, it's a pretty complex, multi-step process that takes raw sound waves and turns them into an incredibly detailed map of what's going on down there.
You can really break it all down into 4 main steps. Step 1, you generate the waves. Simple enough. Step 2, you've got these super sensitive instruments on the surface collecting all the echoes. Step 3, powerful computers get to work, crunching all that raw data to build a 3D image. And then the final, and maybe most important step, geologists have to actually interpret that image to figure out where the good stuff, the oil and gas, might be hiding. But here's the catch. This whole process, traditionally, it's been incredibly slow and super complex. So the big goal for the entire industry has been, how do we make this CT scan faster, way more efficient, and, you guessed it, a lot more precise?
And that is where this really interesting partnership comes into play. On one side, you've got BGP. They're the experts. They make the specialized seismic software. And they're teaming up with Huawei, who brings all the digital muscle to the table. We're talking AI for the analysis, high-performance computing for raw speed, and advanced wireless tech to just supercharge the entire operation.
So, the big question is, how do you actually make this whole thing faster and smarter? This is where modern digital tools are stepping in and completely revolutionizing every single one of those 4 steps we just walked through.
Okay, let's start at the beginning with data collection. By building advanced wireless technology right into the seismic sensors themselves, they can now gather and transmit data 5 times faster. I mean, just imagine getting your results in a single day instead of 5. That's a huge leap forward, right at the very start of the process. But the really mind-blowing change happens in that last step, the interpretation. You know the old way? It meant geologists had to manually stare at these incredibly complex 3D images, just poring over them for what felt like forever. The new way? It uses AI to automatically handle things like parameter optimization and analyzing all those underground structures. And the impact here is just, wow. Using AI algorithms boosts the efficiency of this interpretation work by several times. We're not talking about a small little improvement here. This is a total game changer for both speed and accuracy. So what this really boils down to is a massive compression of the timeline. Think about it. These complex calculations that used to take months to finish are now getting done in just a matter of weeks. That's all thanks to these new AI for science applications running on some seriously powerful hardware. Of course, none of these incredible software and AI tricks would be possible without some serious hardware muscle flexing behind the scenes. So let's pull back the curtain and look at the actual infrastructure that's powering this entire operation. First up, you've got the computing engine. This is basically the brains of the whole system. The GeoEast software is optimized to run on Huawei's Kunpeng processors, which means it's been tuned to squeeze out every last drop of performance for these incredibly demanding tasks. And the results? They speak for themselves. This setup is delivering processing speeds that are 2 to 3 times faster than other similar servers. Now, when you're dealing with a 3D model of the Earth's crust that's the size of a city, well, that kind of speed boost isn't just nice to have, it's absolutely critical. Okay, next problem. Where do you put all this data? We're talking about absolutely colossal 3D models. It's just a staggering amount of information, and it demands a super specialized, incredibly tough storage system, kind of like a virtual Fort Knox for geological data.
Just how massive are we talking? Well, this whole system is built for what's called exabyte-level storage. To give you some perspective, one single exabyte is a billion gigabytes. Yeah, it's a number that's almost impossible to wrap your head around, and this storage was built from the ground up just for this task.
And finally, you got to connect the brains, the computing, to the vault, the storage. That's where a high-performance network comes in. Think of it as a dedicated data superhighway. It has to be super fast, with almost no delay, and it absolutely cannot lose a single bit of data. This ensures those gigantic files can fly back and forth quickly and perfectly, without a single error. So when you put all of these pieces together, the smarter software, the AI doing the heavy lifting on interpretation, and that beast of an infrastructure powering it all, what you get is really a brand new era for energy exploration.
The end result is what they're calling a dual leap. First, you get a huge leap in efficiency, right? It lets them find resources so much faster. And second, you get a leap in precision, which helps them pinpoint those resources with incredible accuracy. It's all about working faster and smarter. And that's a big deal because it can mean lower costs and, maybe most importantly, a smaller environmental footprint since you're not drilling in the wrong places often.
And that kind of leaves us with one last big question to think about. As this technology gets even better, and we get to the point where we can find these resources with almost surgical precision, what does that mean for our energy future? How is this incredible new view of what's beneath our feet going to shape the world for all of us living up here on the surface?